Hello everyone. So today in week 7 we will discuss about operating system and we will discuss the comparative study of different operating systems, right? So it's a analytical deep dive, and instead of talking about that what each operating system does, we will talk about why, that what are the design philosophies that shape everything from security to the user experience. And our main goal is to equip with a framework for evaluating any system software, right? So the topics which we are going to discuss today, that is first of all that what the operating introduction and core concepts, then we will deep dive into the desktop operating system analysis, then mobile operating system analysis, and then we will do a cross platform comparison. So let's start. So before we start comparing the operating system, let's quickly recall that what's the universal job of an operating system. So, as we have studied all the semester, that it's a resource manager, right? And it abstracts the messy hardware into a clean, manageable interface. Or whether it's a scheduling process or managing memory or handling files, all operating systems must perform these core functions. So the critical insight for today is that while the what is the universal process management, memory management, etc., and how is where these philosophies diverse dramatically. So this is basically the how is that what we are dissecting today, right? So the importance of comparative analysis. You must be wondering that why we spend a whole lecture on this. Actually, it is practical, and you will constantly need to choose the right tool for the right job. Like for example, that should you deploy your web app on a Linux server or on a Windows server, or develop an iOS or Android. And also it will teach you about the fundamental engineering trade-offs, right? You cannot have maximum openness without some security compromises, and you cannot have even a perfectly walled garden experience, right? Without sacrificing customization. So we need to understand these trade-offs, uh, because these are the hallmark of a good computer scientist. And finally, it's a fantastic way to see the theoretical concepts that we have covered, like the virtual memory, scheduling algorithms, that how these are applied in real world, and how these implementations compete. So the evaluation criteria which we will use to perform the analysis, we will use it, we will check it against the five pillars. Design philosophy is the most important. It is the founding principle that dictates all others, right? In this, we will check that was it built to be open or closed, and for the server room or the living room, like that, like questions. Usability examines the human computer interaction, and security looks at the mechanism in place to protect the system. Performance considers resource efficiency, and the software ecosystem is about the applications and tools available. So keep this criteria in mind as we go through each operating system. So a brief history of modern operating systems. Context is the key actually. So this timelines shows the language. Notice that Linux and Mac OS share a common ancestor in Unix from the 1970s, which explain why many of their structural similarities. Windows, on the other hand, comes from the DOS lineage, so which was a single user, single tasking system, and later more robust anti-kernel. The 2000s saw the rise of mobile, while forced a complete rethinking of operating system design for touch interfaces and constrained resources. So, understanding this history helps explain why these systems are the way as they are today. So, let's first start the deep dive into the desktop operating system analysis. Okay, so operating system analysis, in which we will discuss about your Windows, Linux, and Mac. So let's start with the Microsoft Windows. Windows is the ubiquitous desktop operating system. Its market share makes it the default target for most consumer softwares and unfortunately for the malware authors. Its target audience is incredibly broad, from casual users to the gamers to large enterprises using Active Directory and Windows Server. Design philosophy of Windows, the I will say that the cornerstone of Windows philosophy is the backward compatibility. The ability to run decades old software is a massive strength of businesses, but also a significant burden. The operating system must carry the weight of legacy APIs and security models. Its code is proprietary, controlled entirely by Microsoft. So, the one window vision aims to create a cohesive experience across different form factors through this has been challenging to execute perfectly. Yep. Then usability and user experience. So Windows excel at plug and play hardware support. You can be fairly confident that any peripheral will just work. Whether it's a printer, it's a mouse, it's a keyboard, anything. You just plug and play and you can use it. Its GUI is familiar and intuitive for billion of people. However, this ease of use for the average consumer often comes with the cost of low customizability. Power users might find the registry editor and system settings less coherent than the configuration files in the Linux. The term bloatware or pre-installed software is a common criticism here, which can slow down the new machines. The security model, if we talk about the Windows security model, so Windows security journey is interesting actually. Its popularity made it the primary target for the viruses and spywares in the 2000s. Microsoft responded by hardening the operating system. Users access control, which is called as UAC, was a major shift, forcing users and programs to explicitly approve administrative actions. Windows Defender is now a top tier built in antivirus. However, the need to maintain the backward compatibility means the attack surface remains large. It's a constant battle between the legacy support and modern security. Then let's talk about the Linux. It's crucial to understand that Linux is technically just the kernel. The operating system is the combination of the kernel with the GNU tools and other softwares packaged together as the distribution or a distro. This is why its desktop market share is small, but its dominance in every other area like server, embedded systems, cloud infrastructure is almost absolute. When you use an Android phone or visit a website, you are almost certainly interacting with a Linux machine. If we talk about its design philosophy, so Linux is the, I'll say, poster child for the open source philosophy. The source code is available for anyone to see, modify, and redistribute. So, this leads to a community driven development model. The philosophy is one of the modularity and choice. You can swap out almost any component from the desktop environment to the init system. The everything is a file abstraction, simplifies interactions with the devices, processes, and system settings because in Linux, everything is treated as a file. Then usability and user experience. So this is the area of greatest change. Distros like Ubuntu have made huge strides in user friendliness. However, the true power of Linux often lies in the command line interface. The learning curve is steeper, but the payoff is immense control and automation capability. The downside is the fragmentation. A GUI application designed for one desktop environment might look out of place in another. While hardware support is excellent for servers, Desktop users might still face issues with cutting edge graphics cards or specialty peripherals. So these are the weaknesses. Then, security model. So, is Linux more secure? That is the first question which we think. It is most accurate to say its security model is different and often more robust by default. The strict separation between the root users and the standard users is fundamental. And the repository model, where the software is installed from the curated sources, dramatically reduces the risk of malware compared to downloading random executables from the web. Most importantly, its transparency means security vulnerabilities can be spotted by thousands of developers worldwide and patched quickly. Then let's talk about the Mac OS. So, Mac OS actually occupies a unique niche. It has a much smaller market share than Windows, but a very local user base, particularly among developers and creative professionals. Its the key differentiator is that it runs exclusively on Apple hardware. This tight integration allows for a level of optimization that is difficult to achieve on commodity PC hardware, but underneath its beautiful GUI, it's a certified Unix system which gives it serious technical credibility. The design philosophy of macOS. So, Apple philosophy is it just works. This is achieved through vertical integration, controlling the entire stack from the hardware to the software, and this is opposite of the Windows model actually. The goal is here a seamless, polished, and consistent user experience. It is a proprietary system, but because it is built on Unix foundation, so it inherits the stability and power of that heritage. Usability and user experience of Mac OS. So the Mac OS interface is renowned for its consistency and aesthetic polish. The trackpad and the gesture support are industry leading. It comes with a strong suite of built-in applications. The downside of vertical integration is that is the Apple tax. You are limited to their hardware, which is often more expensive. It is also not a primary platform for PC gaming, as most games are developed for a much larger Windows market. Then, security model. Mac OS employs a walled garden approach. Gatekeeper by default only allows apps from the Mac App Store or from identified developer who have signed their apps with Apple. System integrity protection is a crucial low-level feature that locks down critical system files even from the root user, preventing many types of malware. And sandboxing for app Store apps is strictly enforced. So this curated model makes macOS a very secure platform, though not immune to the targeted attacks. Then let's discuss about the comparison table between the different operating system, um, desktop operating systems. So you can see there are different trade-offs between the design philosophy, cost, customization level, software installation, target users, and all. So there is no best here, only the best for a particular purpose. Because some, like Mac OS, offers a premium integrated experience at a higher cost and with less hardware choices. Windows offers broad compatibility and ease of use for mainstream tasks. Linux offers freedom and customization but demands more technical knowledge. So, use case scenario. So, when do you choose which? If the primary goal is gaming or you need to run specific business softwares like AutoCAD or some, then Windows is the obvious choice. If you're running a web server, doing software development, or working with big data, then Linux is the dominating platform. And if you are value a stable, hassle free Unix based environment for development or creative work and are willing to pay a premium, Mac OS is an excellent choice. Then, let's discuss about the mobile operating systems. So, and mobile operating system, which is basically they are dominated by a duel between the operating system Android and iOS. So let's start with the Android. So Android is the global market leader in mobile. It's important to note that its structure, the core Android open source project is open, but the Google mobile services, the Play Store, Gmail Maps are proprietary. So it's based on a modified Linux kernel, making it a cousin of the desktop operating systems we just discussed. The design philosophy of Android. So the design philosophy was openness and accessibility. By making AOSP open, Google allowed any manufacturer to use it for free. This led to its massive global adoption. However, this freedom also caused fragmentation. Samsung's One UI, Xiaomi's MUI, and stock Android are all different experiences and they all update on different schedules. This is the central trade-offs of the Android model. If we talk about the usability and customization, so the strength of Android is the choice. You can change launchers, set default apps, and customize your device extensively. There is a device for every budget. The weakness is inconsistency. The experience on a Google Pixel is very different from a Samsung phone, which can be confusing for users, and carrier added bloatware can also degrade the experience on some devices. The security model. So, Android security has improved dramatically. The runtime permission system, where you grant access to features like the camera, that when the app need it, it's very effective. However, when the primary challenge is again fragmentation here, so when Google releases a security update, it must then be adapted by each manufacturer and rolled out by each carrier, leading to the significant delays for the many users and leaving them vulnerable. The ability to sideload apps from outside the Play Store also increases the risk. The next one comes the iOS. So iOS is the Apple's mobile platform. Like macOS, it is closed source system that runs exclusively on app's own hardware, like iPhones and iPads. It holds a significant share in key markets like the US and Japan and is known for having a user base with high engagement and spending. The design philosophy of iOS is basically quintessential walled garden. Apple exercises complete control over the hardware, the operating system, and the App Store. The philosophy is the opposite of Android's initial openness. The goal is to provide a perfectly predictable, simple, and secure user experience by limiting variables. You trade freedom for simplicity and security. Then usability and ecosystem of iOS. So iOS is known for its intuitive and consistent user interface. The App Store is tightly curated, generally leading to the high quality apps. Its greatest strength is ecosystem lock-in. The seamless integration between iPhone, iPad, Apple Watch, and Mac creates a powerful incentive to stay with Apple's world. The weakness are the lack of customization and the higher price points. The security model of iOS is often considered the gold standard for mobile security. This is due to the extreme measures like mandatory app sandboxing and rigorous app store review process, and the most importantly, unified and timely updates pushed directly from the Apple to all supported devices simultaneously. The secure enclave is a dedicated hardware chip that stores biometric data like fingerprints and face IDs, making it incredibly difficult to breach. Again, if we draw a table between the uh, Android and iOS, so the table highlights the fundamental dichotomy. So Android offers choices for and it offers customization, but struggles with consistency and timely security. And iOS offers a uniform, secure, and simple experience, but limits your freedom and charges a premium. It's a clear illustration of the philosophy's trade-off as we discussed earlier. So then the next part is the cross-platform comparison and synthesis. So now let's bring these worlds together and look at the bigger picture. So the security showdown, the desktop versus mobile models. Why are mobile operating systems perceived as more secure? Actually, it's not a magic, it's a design. Mobile operating systems were built from the ground up for the with the security first. They made app sandboxing mandatory and strict, and they established curated app stores as the primary or the only software source. They introduced granular runtime permissions. So desktop operating systems are now playing catch up. Windows has its store and sandboxed apps, and Linux has containerized formats like Snap and Flatpak. The mobile security model is becoming the new standard for all computing. So, if we see the philosophy spectrum between freedom to customization to security and simplicity, so this spectrum visually encapsulates our entire discussion. On the far left, you have total freedom and customization with Linux, and on the far right, total security and simplicity with iOS. Every other operating system falls somewhere in between. So, where would you place your ideal operating system? So, this trade off is one of the most fundamental in software engineering. If you see here, the total freedom and customization is with Linux, and on the far right, the total security and simplicity is with the iOS. So, every other operating system uh, which we have studied falls somewhere in between. Like since Linux offers complete transparency and modifiability, so it is at the extreme left. You can change anything from the kernel up. This represents maximum freedom but also maximum complexity and responsibility for the user. Android moves slightly rightward. So while its core AOSP is open, real-world implementations include proprietary Google services and manufacturer customizations. So this creates the fragmentation, as we discussed, are direct consequences of its openness. In the middle, if we say the Windows, so Windows occupies the center. It's proprietary but designed to run on countless hardware configurations. And Microsoft prioritizes backward compatibility over philosophical purity, making it practical compromise for the mass market. Then Mac OS moves us towards the right. So it's proprietary and locked to Apple hardware, but it retains its unique soul giving technical users power within a controlled environment. And finally, the iOS represents the ultimate walled garden, complete control ensuring simplicity and security, but at the cost of user freedom. So if you see the key trade-offs along the spectrum, so there is nothing about good versus bad. It's about the fundamental engineering trade-offs. Like open system gives you flexibility but requires more technical expertise and vigilance. Closed systems offers convenience and security but limit your choices. So where the operating system falls in this spectrum, dictates virtually every aspect of its design, from security models to the update mechanisms. So Basically, as you move toward a future where all operating system sacrifices some freedom for, greater security. So basically, understanding this spectrum helps you make informed choices. Like if you're developing security critical software, you might prefer the right side's controlled environment. If you are building innovative systems tools, so the left side's flexibility is essential. So there is no universally correct position, only what is appropriate for your specific needs. If we talk about the future trends, so looking ahead, the lines are blurring. Convergence is a key trend. macOS can run an iOS apps, and Windows has the Windows subsystem for Linux. And Android app support is there. So cloud-based operating systems like Chrome OS are shifting the focus from local resources to the web. Privacy is a major selling point for all the platforms now, and the AI integration is moving from a feature to a core component of the operating system. So, with the assistants managing our notifications and schedules proactively. So, the key takeaways I will say here. So, what the should you remember from this analysis? And first, the most importantly, there is no single best operating system. The best choice is a function of users' needs, skills, and priorities. And second, the design philosophy is the root. It dictates the trade offs in usability, security, and freedom. And finally, the industry is converging on a more secure, sandboxed, and curated model, even on traditionally open platforms. So, with this comparative framework in mind, let's wrap up our course and talk about that what we have covered till now. So over the semester, we have journeyed over the fundamental abstractions of processes and memories to the intricacies of the file systems and concurrency. And this lecture on the comparative analysis is the capstone, basically allowing us to see how all those theoretical components fits together in real world systems. So you are no longer just the users of operating systems, you are the informed individuals who understand the machinery underneath. So that's all for the operating systems. Thank you. Bye. Take care.